We're going to be focusing on logarithmic functions. Remember that logarithms are the inverse of exponential functions. And if we were to say that y is equal to log base b of x, that is the same thing as b to the y equals x. Those two things can be rewritten. Now, when I'm trying to remember how to rewrite, I often will write log base b of x equals y, and then I will start at b, loop around from y, and go to x. So that's b to the y equals x. Now we are going to be considering b as a number that is greater than 0, that is not equal to 1. When that is true, you're talking about some base that is being raised to a power to get an x value. So any number, whenever you have b to a negative number, let's say b to the negative n, that's equal to a fraction of 1 over b to the n. Let's say you have b to the 0 power, that's just one whole, and b to the n is going to be b to the n, where you have some number to a positive value. But notice that none of these are going to turn that expression into a negative. So our domain is not going to be in the negatives. So we need to consider the fact that our domain goes from 0 to infinity. And it does not include 0 because, again, raising b to any power is never going to get us to a 0. We're either going to get fractions, we're going to get large, or you're going to get whole numbers, or you're going to get the value of 1, but you're never going to get to 0 or negatives. Now, the range, the y values, can take on any value because I can raise b to any power to get out some result. So if I'm dealing with a fractional x, b is going to be to a negative, so that y would be negative. So if I'm talking about my domain here is x, if I'm plugging in any number from 0 to infinity, that's saying b to some power. Now, negative power, the y, negatives would give you a fraction, and positives would give you positive numbers. So my range can be any number from negative infinity to infinity. So the whole real number system works. In addition to the logarithmic functions being inverse of exponents, there are logarithm laws that we can use to rewrite expressions if we want to. We can expand and we can condense logarithmic expressions. Remember the laws of exponents. When you have x to the m times x to the n, that's x to the m plus n. X to the m divided by x to the n is equal to x to the m minus n, and x to the m to the n power is x to the mn. Now, logarithm base b of that multiplication can be separated into addition. Log base b of x plus log base b of y. The logarithm quotient can be separated into subtraction. And the logarithm exponent can be written as multiplication of the exponent times the logarithmic expression. A few other properties that we have because of inverse rules. The log of base b of b to the x is equal to x. Now think about this. Moving the exponent in front, we get x times the log base b of b. Well, b to what power equals b? 1. So this expression here is 1, which is why that expression just becomes x. Then again, b raised to log base b of x is equal to x. Rewriting this using logarithmic expressions, that is the log base b of x is equal to log base b of x. Converting that using the statement above, where y equals log base b of x and b to the y equals x are equivalent. Okay. A couple of other common properties that we use in calculus. The natural log is log base e and we use ln instead of log. A lot of things in calculus are assumed to be with base e. Remember that the e to the x has the slope of the tangent line at 1. It's that special property that we use. Now, the e to the y equals x, again, is the same thing as the natural log of x equals y, rewriting using those properties. Using the two that we just defined, then the natural log of e to the x is just x, and e to the natural log of x is equal to x. And again, the natural log of e is equal to 1 because the natural log of is log base e, so e to the 0 is 1. Okay, there are the change of base formula. There is the change of base formula, which can help us when we don't have a particular base that we are able to use. The older calculators don't have the capability to change your base. Newer calculators do, so you don't necessarily use the change of base as much, but it does help you when you're trying to calculate and you don't have those calculator tools. So the change of base formula puts the base on the bottom and the number next to it above. Like, let's say I had log base b of x. That's the log of x over the log of b, using log base 10, and there's a log base 10 button on your calculator. There's also a natural log button on your calculator, so that could be the same thing as the natural log of x over the natural log of b. Either one of those would work, so you can evaluate a log that way. That's also how we would solve our exponential equations. Let's say I had b to the y equals x, and I wanted to know what y was. If I didn't remember to rewrite it using logarithmic form, I could take the natural log of both sides, or the log of both sides, and I would get the log of b to the y is equal to the log of x. Moving the exponent in front is y times the natural log of b is equal to the natural log of x, and solving for y is equal to the natural log of x over the natural log of b, which is your change of base formula. Okay, so that is an overview of logarithmic functions.